A project passes through various phases from the start to the end. This is called the project life cycle. The simplest life cycle a project can have is start a project, do the project, and finish the project. However, this is not how a project is broken down into phases. As an example, a project may have phases of requirements, design, develop, test, and deploy, or design, permit, construct, inspect, and handover phases. The generic life cycle is the same: start the project, organize and prepare, do the work, and end the project. How the deliverables will be created and handed over can occur in different ways. These can be sequential, that is, one after the other. One phase ends, then the next one starts. For example, design finishes and then construction starts. Or these phases can be overlapping. One phase is midway and the next phase starts and does not wait for the first phase to finish. For example, design is half done and the construction starts. Or it can be iterative. For example, some design is done, then some construction done, followed by some inspection and handover. Then the next sequence of the same phases starts. Some more design, construction, inspection, and handover. There are 5 different types of development life cycles. Let us understand these one by one. The first is predictive life cycle. This life cycle is used when the scope can be defined well at the beginning of the project. Once the scope is established, a good time and cost estimate can be prepared. The approach is to collect all the requirements, define all the scope, design all of it, develop all of it, test all of it, and deploy all of it. With this approach, what happens if a change is requested? Let's say during testing. Such a change is hated by the project team because it now requires redoing designing, development, and testing. It will require quite a bit of rework. So any change proposed is evaluated thoroughly to ensure impact is minimum. This is why the predictive approach is also called fully plan driven approach. In IT projects, it is called the waterfall method, signifying that project proceeds one way only, like water flows one way only. Second is iterative life cycle. This life cycle is taken up when the high level scope is well known at the start, but it is too big. In that case, there might be a need to revise the time and cost estimates several times as the project progresses. Also, a big benefit of taking this approach is that part of the scope that is complete can be put to use, handed over to the customer or user so they can start using it. It is a good way to get feedback on the delivered scope and modify the current and future work if needed. Let us say a large university decides to move its campus, buys 200 acres to put up about 30 buildings in 10 years. 2 buildings are up in 2 years. Should these be put to use, or the project team should ask the university to wait for another 8 years before all 30 buildings are up? Handing over the 2 buildings for use has 2 main benefits: early feedback that can help later work, and early realization of business benefits. Third is incremental life cycle. In this life cycle, the deliverable is built in increments. This is common in software applications development, where with each iteration or after few iterations, more and more functionality is added to the application. In other words, the application is not considered complete until the final iteration. The key difference between iterative and incremental is that iterative delivers large chunks a few times, while incremental delivers smaller pieces frequently. Iterative gets estimates reviewed frequently, and based on feedback, the details may get revised several times, but this happens much less often in the incremental approach. Then the fourth life cycle is the adaptive life cycle. The iterative and incremental life cycles are kind of adaptive life cycles, but the clearly adaptive life cycle is agile. In agile, the project objectives are set at the start, but the scope is not well known. Or the project has an objective, but how this objective can be achieved is unknown. So the approach is to take small steps in the form of iterations, each only 2 to 4 weeks long. Detailed scope of work is defined before iteration and at the end. The results provide feedback which helps in defining and selecting the work for the next iteration. This method is now commonly used in the software development world. Let us take a non-software example: sending humans to Mars. Humans have fancied travel to Mars for a long time. Various countries and agencies have set up plans to send people by certain years, around 2018, then 2024, and also 2030. So the goal was to have people on Mars by a certain year. If someone asked how, the answer was, we have no idea. So how are humans supposed to proceed when the goal of sending people to Mars is there, but how to achieve that goal is unknown? Take the adaptive life cycle. Run short iterations. In this case, these could be a year or more long iterations. Develop new knowledge that gets added to current knowledge, and then based on that, go for next iteration. This is what humans have been doing. One of the big challenges of human to Mars is getting them alive. We did not know what will happen to the human body if it stays out of gravity for a long time. So we sent out astronaut Scott Kelly and made him stay at the International Space Station for 11 months. He was observed continuously while his twin brother who stayed on Earth was also being observed. When he came back, he was tested heavily for almost a year, and we learned a lot from that. Now we know that if humans stay out of gravity for a long time, they get kidney damage, lungs damage, heart damage, brain damage. Their bones become brittle and they lose height, and even their DNA changes. In other words, we cannot survive without gravity for long. This new knowledge has helped decide the next iteration. One of the things being looked at is how to create artificial gravity in a spacesuit to give the human body the feeling as if it is still on Earth. So this is what agile approach and adaptive life cycle looks like. Now the fifth life cycle is the hybrid life cycle, a combination of both predictive and adaptive life cycles. Some parts of the project will be taken as predictive because the scope is well defined and definite time and cost estimates can be set up, but other parts which are not well known will be taken as predictive. Some organizations have created tools to help project managers select the right developmental life cycle for their projects. So there are 5 common development life cycles: predictive, iterative, incremental, adaptive, and hybrid.